Hello friends, welcome to Zeta Axis, and today we will discuss about volcanoes. In this topic we will discuss how volcanoes are formed, what are pyroclastic flows, what kind of gases are emitted by volcanoes, what are the effects of aerosols released from the volcanoes, why volcanoes erupt with explosion, distribution of volcanoes across the world. Now let's begin with the word volcano and volcanicity. Volcano means an opening on Earth's surface through which heated materials from Earth's interior consisting of gases, lava and fragment of rocks are ejected. Now remember, the opening could be anything. It could be a crack, it could be a hole, it could be a fissure. So any kind of opening through which these materials are emitted is called a volcano. On the other hand, the word volcanicity means the whole process of volcanism, right from the magma rising in the crust to emerging on the Earth's surface and solidifying to form rocks. All these steps are included in the word volcanicity. Now let's see why volcanoes are formed. Around the world, all the land masses have a weight due to gravity, and because of which they apply a downward pressure. This downward pressure of gravity is balanced by an upward pressure of buoyancy generated by asthenosphere. Now at all these places, both of these forces are in balance, as you can see here. But if an imbalance is created between these two forces, for example, if gravity is suddenly reduced here, then buoyancy will be more than gravity, and this increase in buoyancy due to the reduction in gravity will cause the magma to come on the surface. So any imbalance in the gravity and buoyancy leads to volcanism. We will discuss all of these topics in a different video, the link for which is available here. Now the balance between gravity and buoyancy is disturbed because of each of these processes, and each of these processes affect this balance in a certain way. Let's see how volcanoes are formed. We already know that there exists a downward acting gravitational force and upward acting buoyancy force, and at all locations both of these forces are in balance. But if due to some reason an imbalance is created and buoyancy force becomes greater than gravity force, then it will force the magma from asthenosphere to rise up. Now we already know that this magma is hot and less dense, therefore it has high buoyancy. This magma, when rises up, it melts the rocks of the overlying structure. These rocks, after getting melted, will add to the magma. Therefore, they will increase the volume of the magma. Secondly, they will also change the characteristics of this magma, because the magma which comes from the asthenosphere is basic in nature. But as this magma rises, it melts the continental crust rocks, and these continental crust rocks are added to the magma. But we know that the continental crust is rich in silica. Basic magma has less silica. But since continental crust is rich in silica, the rocks which are melted and added to the magma are also rich in silica. So it increases the silica content of the magma from the asthenosphere. So the larger distance magma will travel in the continental crust, the more acidic it will become, because more and more rocks are melted and added to the magma, which makes it more and more acidic. Now this magma, when it rises, it may encounter a rock layer through which this magma may not be able to pass. Therefore this magma continues to accumulate beneath this rock layer and forms a magma chamber. In this magma chamber, the amount of magma continues to increase because magma continues to rise from the asthenosphere. This increase in magma exerts pressure on the overlying rocks. Moreover, this magma continues to melt the rocks surrounding it. So these rocks also add to the magma and apply a pressure on the overlying rocks. Another important phenomena occurs, like in our soda bottle. So here you can see that there are no bubbles in this soda, because CO2 has been mixed with it at high pressure. But as soon as I release the pressure, you can see a large number of bubbles are formed. Similar thing occurs here. At this depth, due to huge pressure, the volatile elements are in soluble state. But when they come up, the pressure is reduced and the volatile elements are no more in soluble state, but they form gas bubbles. These gas bubbles also apply a force on the overlying rocks. Because of increase in the pressure from the magma, the overlying rocks may melt away or may develop cracks through which the magma rises up. This magma, when reaches the surface, it erupts. It gives out lots of smoke. As well as during cycles of eruptions, what will happen, that layer upon layer of tephra, that is volcanic rocks, as well as magma is created, and we see a large mountainic structure is created by repeated eruptions. Pyroclastic flow is seen. Pyroclastic flow is like flow of fragmented rocks along with smoke. They flow downhill from the mountain slopes at a very high velocity. They flow at a speed higher than magma. These lava bombs are also thrown up in the air. These are hot rocks which are thrown in the air, and they could travel several kilometers. Now, along with this main vent which brings the magma from the magma chamber to the crater, there are also some other secondary vents. Some of these vents may reach the surface of the volcano, and it is called parasitic cone. Some other vertical structures formed by this magma are called dikes, while the horizontal ones are called sills. Certain gases are also emitted. The most important one are carbon dioxide, water vapor, and sulfur dioxide. Along with these gases, aerosols are also emitted by the volcanoes. Now, carbon dioxide and water vapor are greenhouse gases which increase the temperature of the earth. These gases absorb the radiation emitted by the earth, and thus they increase the temperature of the earth. So that is a negative impact on the atmosphere. Sulfur dioxide increases the albedo of the clouds in the stratosphere. This has a positive impact on global warming because increase in albedo means the more amount of light is reflected back to the space. So basically, an increase in albedo means the amount of light reaching the earth is reduced. But there are other negative effects. This sulfur dioxide causes acidic rains. It is also an indirect greenhouse gas because it does some processes through which greenhouse gases increase. Aerosols or dust particles also increase the albedo. What they do is they increase the amount of radiation coming from sun reflected back to space. So they reduce the amount of radiation from sun that reaches to the earth's surface. Thus, it reduces the amount of heat within the atmosphere. However, it causes variation in the rain patterns. Aerosols are important for rains, but if their quantity increases substantially, then they will change the rain pattern. They also cause melting of glaciers. This is by the process that these aerosols over time will settle down on the earth. Some of these aerosols will settle down on the glaciers. Now, as they settle down on the glacier, they will decrease the albedo of the snow. What it means that because snow is white in color, it will reflect more light. It reflects more light, so there is less heat. But because of distribution of dust particles, they absorb more light because the dust particles are black in color. And because they absorb more light, they will increase the temperature of that region, and thus they will cause melting of the glaciers. Now let's quickly revise what we have discussed in volcanism so far. We have seen that the hot magma is less dense than the surrounding rocks. Therefore, due to buoyancy, this magma rises up. On the way up, this magma keeps melting the lithosphere, and the lithosphere which gets melted gets added to the magma, thus increasing the total amount of magma. Now they also change the nature of the magma because continental crust is sial in nature, that is acidic in nature, while the magma which comes from asthenosphere is saima in nature, that is basic in nature. So as the distance magma travels through the continental crust, more acidic it will become because of the addition of continental crust rocks which are acidic in nature. Therefore, the greater distance it will travel in the continental crust, the more acidic it will become. Magma, when encounters a layer of rock which it cannot break, it starts to accumulate and forms a magma chamber. With time, more amount of magma reaches to this magma chamber by melting as well as from the asthenosphere, thus overall pressure on the overlying rocks increases. The pressure on this magma also reduces because it has traveled to certain height. The volatile elements which were dissolved in the magma here are no more soluble. but they become insoluble and they form bubbles. These gaseous bubbles also apply a pressure on the overlying rocks. Because of all this, the pressure on the overlying rocks increases and this magma is finally able to break through it. This magma then reaches the surface and forms volcano. Now magma when reaches the surface, it breaks through the layers and an explosion occurs. The type of explosion will depend on the viscosity of magma and the amount of dissolved volatile elements. We have seen that dissolved volatile elements forms gaseous bubbles. So the explosion will depend on the viscosity and the amount of dissolved volatile elements. Pyroclast elements are thrown up and they flow through the slope of this volcano. A pyroclastic flow is basically a flow of smoke mixed with rock fragments. Volcanic gases are also released which mainly contain water vapor, carbon dioxide and sulfur dioxide. Now here we can see that by repeated eruption of magma from the volcano, we see a layer of tephra and lava is formed. And because of this repeated layer formation, we see that a huge structures are formed. The great height of volcanoes is formed. So we see here stratovolcano and over here we see a sealed volcano. We can see both of these volcanoes are formed by creating layers, by deposition of layers of tephra and magma. Now pyroclastic flow, you can see here in this image what is pyroclastic flow. It is moving downhill from a volcanic mountain and it is a giant gas structure mixed with rock fragments. See, it is a mixture of volcanic gases and rock fragments and air which move downhill with very high speed. The speed of pyroclastic flow is more than lava. Now pyroclastic flows are different than lava flows. Lava flows on the ground while pyroclastic flows can extend from surface to few meters above the earth's surface. You can see here that this pyroclastic flow is not only restricted to ground but it can move even higher. Now pyroclastic flow is very fast while magma flow is slow compared to pyroclastic flow. Pyroclastic flow contains hard or semi-solid rocks while magma is completely fluid. Now certain gases are emitted by volcanoes. We have already seen that it emits water vapor which is a greenhouse gas. It increases the temperature of the atmosphere. It also increases the amount of precipitation in atmosphere. So more rains will occur in the regions where volcanism occurs. Carbon dioxide which is released from volcanoes is also a greenhouse gas. It increases the temperature. Moreover, it increases the acidification of ocean. Sulfur dioxide reacts with water vapor to form sulfuric acid and it causes acidic rain. Sulfur dioxide can reach to stratosphere or even higher levels and it forms aerosol particles through various reactions. These aerosol particles help in the formation of stratospheric clouds which lead to ozone holes. Moreover, they provide a layer over which there are certain reactions occur which release the chlorine which destroys ozone in the stratosphere. Now let's see specifically effects of aerosols released from the volcanoes. We have seen that the aerosols which are released, they increase the albedo. That is, they reduce the amount of radiation coming from the sun towards the earth. Here you can see that a part of radiation which is coming is reflected back to space by the aerosols. Therefore, global temperature is reduced because less radiation comes to our Earth's surface, less heat is produced. These aerosol particles negatively impact the ozone because they provide a surface over which the chlorine reservoirs. Chlorine reservoirs are such chemical compounds in which the chlorine is in stable form. However, because of aerosols, these chlorine reservoirs react and they are released freely in the atmosphere. HNO3 is formed between these two reservoirs and we see that chlorine is now free and this free chlorine now reacts with ozone to destroy it. These aerosols also help in the formation of stratospheric clouds, which are again a cause for destruction of ozone. These aerosols, when they come to the troposphere, they can cause rainfall. If there is large amount of aerosols, there will be a large variation in the rainfall pattern. Now volcanoes erupt with explosion for two reasons. The first is dissolved gases expand at rapid rate when magma reaches surface. So we have already seen that the pressure on magma reduces as magma rises through the crust. And when it reaches the surface, the pressure is completely released. Now we have seen that at high pressure, volatile elements are dissolved in the magma. But when the pressure reduces, these volatile elements are no more dissolved in magma, but they become insoluble. They form gas bubbles. These gas bubbles expand at rapid rate when the magma reaches the surface and pressure is completely released. Moreover, viscous magma during the process of eruption solidifies in the wet. If it is very high viscous, it will solidify very quickly. So for the next cycle of eruption, the magma has to break the solidified viscous magma. Explosiveness of volcano depends on viscosity of magma as well as volatile elements dissolved in magma. Volatile elements mean all the elements which on normal gas and temperature. Explosiveness of volcano depends on viscosity of magma as well as volatile elements dissolved in magma. Now volatile elements mean all those elements which in normal state, that is at normal temperature and pressure, are in gaseous state. However, due to pressure and increase in temperature, they are dissolved in magma. Now let's see why explosive eruptions occur. Here we have shown two types of magma, viscous magma and fluid magma. When this magma rises, what happens that the pressure on the magma is reduced. And because of this, the volatile elements which were dissolved in the magma here are no more dissolved here because the pressure is less, and we see formation of bubbles. Now, the bubbles which are formed in the fluid magma can easily escape to the atmosphere, while the bubbles which are formed here in viscous magma, they are not able to escape to the atmosphere because this is a very viscous liquid and they are trapped in that. So finally, when this magma reaches the surface, there are very less bubbles here, but here the amount of bubble is very high, and as soon as it reaches here, it just expands. So all these bubbles expand at an instant, creating a volcanic eruption. And that is why if you have a viscous magma, then eruptions occur with a blast. Now let's quickly revise all that we have discussed. The first is that dissolved gases expand at rapid rate when magma reaches surface. We have already seen that these gas bubbles, when they reach the surface, they expand and create a blast. Magma within Earth is at high pressure. Due to this high pressure, many volatile elements are dissolved in the magma. You can see here that they are dissolved over here. But when magma rises up, the pressure is reduced and we see formation of bubbles. These volatile elements are no more soluble, but they form gas bubbles. Here is an example where we see that this soda water, the CO2 was compressed, and initially when the bottle was closed, the CO2 was not forming bubbles because the pressure was high. As soon as we opened the bottle, the pressure was released and the CO2 formed bubbles and came out with a blast. A very similar phenomena occurs in volcanoes. In less viscous magma, the bubbles can easily escape to the atmosphere. Therefore, very less explosion occurs. But if it is a viscous magma, the bubbles are trapped, and when they come out, there is lot of amount of bubbles and they are just expanding at the same time, creating a very huge blast. Further, the gases in the magma reduces the friction of the rising magma, therefore they increases the velocity of the magma. So magma, when comes out on the surface, it comes out with high velocity as well as it has large amount of gases trapped in it, due to which when it reaches the surface, all these gas bubbles, they just blast simultaneously, creating a huge blast. Now let's see the second reason for explosive eruptions. We have already seen there is a acidic magma and basic magma. So the viscous magma, when it comes to the surface, it does not flow far away from the vent, but it is accumulated there, while the fluid magma can flow far away from it. This viscous magma quickly solidifies over the vent, thus creating a plug over it. While here we have seen that the fluid magma has flown away and not forming a plug over it. Now during the next cycle of eruption, what happens that the magma that is coming out here, it is blocked by this plug. And this magma increases the pressure and it suddenly comes up with huge pressure, breaking the plug and coming out. So it creates a blast. So this is the second reason why we see blast in viscous magma. Again, revising what we have discussed, viscous magma is very sticky. Lava does not flow far from and accumulates near the volcanic cone. A lava dome can be created. We can see here a lava dome is created. Viscous lava quickly cools over and within the lava vent it forms a plug. So we have seen that a plug-like structure is formed over the vent. The solidified lava in the lava vent obstructs the flow of upcoming magma in the next cycle. So you can see that this magma is coming up and it is obstructed by this plug formation, and therefore the pressure on this magma increases. This magma pressure increases and it will break through this plug-like structure to come out, and that is why we see a huge explosion or blast. Now let's see where volcanoes are distributed in the world. You can see here that the volcanoes are generally found in seismically weak zones like plate boundaries. We can see here that there are trenches here, and along the trenches we see a large number of volcanoes. Similarly, there are trenches over here, there is Peruchili trench here, and we see large number of volcanoes here. So volcanoes are generally found around the convergent boundaries of ocean continent or ocean. Let's see the distribution of volcanoes around the world. In this map you can see that the volcanoes are mainly. Let's see the distribution of volcanoes around the world. Let's see the distribution of volcanoes around the world. In this map we can see that the volcanoes are mainly located in the seismically weak zones, that is around the trenches or near the convergent boundaries, that is. Now let's see the distribution of volcanoes around the world. In this map you can see that the volcanoes are located in seismically weak zones, that is near the converging plate boundaries, mainly ocean or ocean continental converging boundaries. You can see here that there is a trench formed here and the Nexa plate is going under the South American plate. Similar thing happens here, Pacific plate is subducting here. So we can see that near the trenches we see lot of volcanic activities. Here over here we see a Sunda trench. Indian plate is moving under the Eurasian plate. So we see that at these margins there is a large amount of volcanism. The volcanic regions can be divided into these four categories: the circum-Pacific belt, which is well known, the mid-continental belt, the mid-Atlantic belt, and the intraplate volcanoes. The circum-Pacific belt includes the region surrounding the Pacific Ocean. You can see here that a tectonically active region is created by the subducting plates. The Pacific plate is subducting under the North American plate, as well as here it is subducting under the Eurasian plate. The Nexa plate is also subducting under the South American plate. So we can see that the tectonically active region has created the seismic activity here, and most of the volcanism here is because of tectonic activity. Some people include the Antarctica volcanoes in this Pacific Rim of Fire. However, most of the volcanoes here are due to hotspots. So some references will include it in the Pacific Rim of Fire while others will not. Cotopaxi is the highest volcanic mountain and it is located in Pacific Rim of Fire. This is a map showing the important trenches as well as mountains of the Ring of Fire. If you would like to note them, please pause the video. This is the mid-continental belt. You can see that volcanoes are created in the mid-continental belt because of the convergent plate boundaries. It includes the Mediterranean volcanoes as well as the volcanoes of Eastern Africa. Then at the mid-Atlantic Ocean, we see that there lies a mid-oceanic ridge. Here, the plates on the North American plate and the Eurasian plate as well as the South American plate and the African plate are moving away. So this is a divergent boundary. Here we see fissure kind of volcanoes where mid-oceanic ridges are formed. Iceland volcanoes are located here and they lie over the mid-oceanic ridge. The fourth type is interplate volcanoes. Here the volcanism occurs within the continental plates, that is far away from any tectonic activities. Now the reasons for each of them is not known and the processes due to which they occur is still being discovered. Notes for all the topics that we discussed will be available on our website zeta-access.com. Thanks for watching the video, and if you like the video, please like, subscribe and share. If you like our effort and like what we are doing, then you can use our UPI ID or Patreon ID to support us. You can follow us on our social media links. Until then, we meet again. Jai Bharat, Jai Gyan. Thank you.